Good morning to all. My name is Anjali Vishwakarma. I'm professor of SIRT. So, in my today's YouTube lecture, I will discuss about the OSI model. The OSI model is a communication model. It is a topic of computer networks. So, in this model, I will discuss how this model works, why we use this model, what applications for this model, why we use this model. So, if I'm talking about the OSI model, so firstly the full form of OSI is Open System Interconnection. The full form of OSI is that, so as name suggests, interconnection. So whenever we want to send a messages from one person to another person, or whenever we want to share some files, then here we have to use a model to sending our files or our data from one person to another person, or from one place to another place. So here I need a model. For this purpose, we will discuss the OSI model. So as I told you that OSI means Open System Interconnection. So this is a model, is a conceptual model that characterize and standardize the internal function of the communication. So it contains different types of layer. By using layers, we can transfer our files, our data from one person to the another persons. So this model is a product of Open System Interconnection project at the International Organization for Standardization. So this is what the OSI model, in which I'll discuss the full form OSI model and define why we use this OSI model. So this model groups similar communication functions into one of the 7 logical layers. As I have told you, it is a collection of layers. So here in the OSI model, there are the 7 types of layers. Every layer have different types of functions, which is different from the another type of layers. So the layers provide error-free connections across the networks and provide secure connection and different types of functionalities provided by these 7 layers. So these 7 layers are physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So this is what the OSI model. If I give a little information about each layer, so the physical layer is used for the binary transmission, and if I'm talking about the data link layer, that it provide the error free and control free transferring of the information. And if I'm talking about the network layers, then it will define the addresses and based route or path. Now the transport layer provide end-to-end connections. Session layer provide the session in which the data will be transferred, and presentation layer define how can we represent the data and we can send. Now the application layer provide different types of protocols. By using protocols, we can send our data information, or we can communicate. So this is all about the OSI layers. So we have to remember that there are the 7 types of layers. Each layers have their different types of functionalities. It provide different types of functions. It provide different types of security, error control, flow control, sessions, presentations, addresses, base route to communicate. This is what the OSI models functions. So physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So one by one I will discuss about the functionalities of each layers. So if I'm talking about the layer network model, so as I told you, there are the 7 types of layer. So the lower 4 layers are transport, network, data link, and physical layer. So these layers provide the different types of end-to-end delivery. Each layers communicate with the same layer, software or hardware. Each layers provide services to the layer above it. So this is what a simple information about the layers. So if I'm talking about the last 4 layers of OSI model, then these are application, presentation, and session layer. Now they also provide data encapsulation, in which it provides security by encapsulating the data. Now, as I told you, one by one I will discuss the functionalities of each layer. So very first layer of OSI model is physical layer. So it provides the physical interface. It define the rules by which bits are transmitted from the one system to the another system, or we can say from the one person to this another person, or here I can say from the client side to the server side as well. So it covers mechanical, electrical, functional and procedural aspects. So physical layer, it also provide the information regarding voltage usage. It provide the timing of the voltage, physical data rates, maximum transmission distance, physical connections and other similar attributes. So this is what the physical layer, in which it provide the connections between the two persons. So there are the different types of function of physical layer. It means it provide the transmission mode, in which there are three types of modes of the transmission, that are simplex, half duplex and full duplex. If I'm talking about the simplex, then data is transferred in a one direction. If I'm talking about the full duplex, half duplex, in which both the side can transfer data but not at the same time. If I'm talking about the full duplex, then both the side can transfer data at the same time. Now physical topologies, in which how we can connect the things for the transmission. This is what the topologies, in which there are the different types of topologies, means bus, star, mesh topology. So it will define how can connect our systems from one to another. We can connect directly, or we can connect from the centralized server. So this is what the physical topologies. It define the bits and transmission rate of the bits. It provides the synchronization. It means it provides the clock in which the bits are transmitted. So this is what the physical layers functionalities, or we can say functions. Now the next layer is data link layer. Then it provides the frames. It implement the flow control. It supports against simplex, half duplex and full duplex transmission. As I told you, what does mean these types of modes. It provide reliable connection over, or we can say it provide a reliable communication over the physical layers. Now these are the functions of data link layer, like framing, physical addressing and error control. It will define, or we can say it can protect from the errors. In error control, it detects, and if there is an error, then it again transmit the data, or if there is loss in data, then again it can retransmit the data. So this is function that is provided by data link layer, that if their data is lost or data is not correct, then it will retransmit the data. And if I'm talking about the framings, so these are, it provide a way for a sender to transmit the sets of bits that are meaningful to the receiver. This can be accomplished by attaching a special bit pattern to the beginning and end of the frame. Now the physical addressing is also provided by data link layer. This is called MAC address of the sender and a receiver. So this is what the functions of data link layer. Now again there are the two another function that is provided by data link layer, that is flow control and access control. If I'm talking about the flow control, then data rate must be constant on the both sides, as the data may be corrupted. Flow control coordinates the amount of data that can be sent before receiving acknowledgement. Now, if I'm talking of the access control, when a single communication channel is shared by multiple devices, the make sublayer of a data link layer helps to determine which device is controlled over the channel at the given time. Now the next layer is network layer, in which it provides the packets. By using packets, we can put the data on the packets, and these packets provide the security because all the data are fit in the packets. It defines the most optimum path or packet should take from the secure destination. Handles congestion in the control, facilitates interconnection between heterogeneous networking. The network layer also defines how to fragment a packet into smaller packets to accommodate different media. It means we can divide the large packet in the small packets and then we send from the above layer. So these two things that is provided by network layer, that is routing and logical addressing. In this routing, it provide the base part to transmission of the data. It provides the suitable route from source to the destination. Now the logical addressing, in order to identify each device, network uniquely. The network layer defines an addressing scheme. The sender and the receiver's IP address are placed in header, while network layer such an address distinguishes each device uniquely and universally. These are the functions of the network layer. It means it provides the route, it provides the base path from sender to the receiver. We can say whenever we want to transfer data from the one place to another place, here we have to first choose the base path, or we can say the shortest path to sender and receiver. The next layer is the transport layer. It provides error-free delivery of the data. It provides two types of connections, that is connectionless and connection oriented. It means we can in transport layer there are the two types of connection, that is connectionless and connection oriented. It provide error free and it is provide reliable mechanism to exchange of data. So if I'm talking about the connection oriented service, then there are three phases in this services, like firstly we can establish a connection, then we can transfer the data. After transmitted data, we can terminate that connection. So this is what the connection oriented services. And if I'm talking about the connectionless services, then it is one phase process, as in connection oriented services. There are the three types of phases. Firstly we connect, then we transfer, and then terminate. But in connectionless, this is the only one phase process. In this transmission, the receiver does not acknowledge receipt of packet. This approach allows for much faster communication between devices, but this is not a secure, because it not acknowledge when the data receive or not receive. So this is for the connectionless services. Now the session layer, it will provide the session, how much time it takes from taking data transfer. Whenever we want to transfer data from one place to another place, here we provide a session. If I provide the session, then we can know how much time it takes from data to received by destination. So the session layer provides mechanisms for controlling the dialects between the two end systems. It defines how to start, control, and conversation. This layer requires for logical connection to be established to end users require any necessary logon password validation is also handled by this layer. So the session layer is also providing terminating the connections. It provides two types of services, that is full duplex and half duplex. It occurs between checkpoints. The data can be retransferred from the last checkpoints. Now this layer is responsible for establishment of connection, maintenance of session, authentication, and also ensures securities, in which we can establish, maintain, and terminate the connection. It provides synchronization. It provides dialog controller. Now the next layer is the presentation layer. So the presentation layer defines the format in which data is to be exchanged between two communication entities. They can also handle data compression and data encryption. If I'm talking about the data compression, it means there's a large, or the data length is too much, then it compresses the data, so the data become less. Now the data encryption, in which we provide different types of encryption technique by which we can transfer this readable data to non-readable data. It provides the encryption decryption, which means we can protect data, we can change data from readable to non-readable form, and we can only know only sender and receiver know the actual data. Other person don't know about the data, because this data is non-readable. So this can be happen by using the cryptography techniques. So there are different types of techniques we use to protect or provide a security for the data. Now the last layer of the OSI model is the application layer, in which we use different types of protocols to transfer the data. So the application layer interact with application programs and is the highest level of the OSI model. Application layer contains management function to support distributed applications. Examples of application layer are applications like file transfer, electronic mail, and remote logging, etc. So whenever we have to provide transferring of the data, then here we use different types of layers, but this OSI model is not implemented. They are only used as a reference model. So we in my next video I will discuss about the TCP/IP model, which is used, or which is actually used to transferring or for the communication purpose. So whenever we have to learn about the TCP/IP model. So the OSI model used as a reference model to understand the TCP/IP model for the understanding purpose and how these things are works. How can we transfer the data? How can we exchange our information, our data, or our files? So firstly, we have to know about how these works. For the understanding purpose, we use as OSI model as a reference model of TCP/IP model. So the function of application layer are a network virtual terminal, FTAM file transfer access and management, mail services and directory services. So thank you for listening.